What is up, everybody? Welcome back to Case Digital. If you missed the eclipse, you are witnessing it now. This is what we're going to program today. So get your eye protection on, and without further ado, let's hop right in and start coding. All right, so to make that solar eclipse, we're going to use a few packages in Python. So if you don't already, I highly recommend for this project, use a virtual environment. You can see that I already have a virtual environment activated here. If you're not familiar with kind of what a virtual environment is, I have a video on that I will link somewhere around here that you can go ahead and go watch. But essentially, to create it, just to kind of give you a little sneak peek of what you do, is you do something like Python -m, -m, venv, and then the name of your virtual environment. Now, oftentimes people call it env. Like for this one, I called it zenv because I was messing with a couple different ones in previous videos. And then once you have that, if you hit enter, you'll need to activate it, and you'll do that by simply saying source, and then you'll do, in our case, like if I were going to do reactivate mine, I would do source and then zenv. I got to be at the directory where it was installed. So in this case, it's up a directory for me. It'll probably be, though, where you run that first command that I just showed you, zenv. And then if you're on a Mac, it's going to be bin. On Linux, it'll be bin, activate. If that's on Windows, it's going to be the environment name /scripts and activate. And then we'll go ahead, we'll just reactivate it. It's already activated. And then we need a few packages. The two packages that we're going to use for this one are essentially going to be matplotlib and numpy, or numpy, however you say it. So you can go install those by going pip install, and then you can say matplotlib, and then space, and then numpy, or numpy. If you want to install them individually, you can do that as well. But I already have these installed, so they shouldn't really install. It just says requirement already satisfied, and I'm good to go. And then from that, we need to actually input them into our script. So I've got this file called solar_eclipse.py, and I'm just going to come up here, and we're going to use within matplotlib, we're going to say import matplotlib.plty, or pyplots, excuse me. Yeah. So we use pyplot. This is very common. This kind of gives us kind of that frame, that access stuff that we'll mess with. And then oftentimes people call this, they say as, to kind of, rather than having to type this whole thing out each time, they say as, and then we'll do plt, okay? And then to create that cool animation that you saw, kind of like the sun going back and forth through there, we'll do import from matplotlib.animation, and then we'll also shorten that by just saying animation. And then the last thing that you'll need to import, like we did, is numpy. So you can say import and numpy. And then oftentimes, this is practice what I've seen. People say, as np. And so just like that, we have all the imports that we need, and we've downloaded everything. We've got them into our file. And from that, we can start coding out the framework of our Eclipse. All right, so now that we have the imports done, let's go ahead and set up kind of our figure that we're going to use to help kind of show this Eclipse. So to do that, we're going to say figure, and then it's going to output also figure, and ax for like axis or a subplot is going to be equal to plt.subplots. Now this is going to basically just create our figure that we can use, right? And then we're going to come down here, and now when we have our figure and our kind of the subplot that it's within, we need to set the access information of like how big, how wide, and all that stuff. So we're going to come down here and we're going to say the x set x lim, and I just did -1.5 to 1.5, and then I did the exact same thing for the y. And then we need to set the aspect ratio. So to do that, you're going to say axis.aspect, and you can pass in set aspect. So when you use this, you can pass in kind of like a specific aspect ratio that you want, or you can set in using kind of like what it says up here, auto or equal, and we're just going to say equal. And then from there, we can go and say plt show. Now, if we go ahead and run this, we'll see what we get from our figure, right? So this may take a minute the first time running this to kind of get set up and going. But once it's set up and going, after that, it should be really fast. All right, so now it's up. You'll see right here, this is not looking like a solar eclipse, Zach. This is looking more like a graph plot or something, right? Well, we're gonna have to show you how you're gonna turn this off. So we're gonna go here, close this, and then we're basically gonna say the ax.axis is off. And now, if I go ahead and rerun this, taking a little bit longer, but now you'll see that there's nothing on here. It's blank, right? So there's our fresh canvas, as you would say, that we can start with. So now, let's kind of add stuff to it. All right, so now we have our frame. Like I mentioned, let's add some things to this. Let's add in the sun, and let's add in the moon. So we can say sun is going to be equal to plt.circle, and then you're gonna pass in, and now we're just gonna do this like everything is at the center of our graph. So we're gonna say the points that it's going to be at are gonna be 0. Oh, that is not a 0. 0, 0, 0, with the size of this being is, we're gonna say it's 1, like with a I believe it's in the, I think it's the radius is 1, and then color, and we're just gonna say is equal to yellow. Okay, and if we do kind of copy that same construct, right, we can build out our moon. So we can say moon, and same thing, but in this case we don't want it to be like, we don't want it to start right at the center. So what I kind of did is, in the X position, we started off, like, as you saw, like, I guess it was from this way, as you saw, it came through like this, and that was because I started at -2, and then I did it so it was just ever so slightly smaller, so 0.97. And then this color here. So the colors, you can type in stuff, or what I found, which I found out interesting when I was researching this a little bit, you can actually do like 0.0, like if you do 0, it's like completely black. But in our case, if you do like 0.1, it's just like still really close to. So how do we go and add this now, right? So we have our sun, we have our moon. Like, how do we go and add these? Well, there's this, with the access, you can do add artist, I believe it is. Yeah, add something, because we're gonna basically draw. So we're gonna add this artist, and we're gonna say, we're gonna add the sun. And then after that, we're gonna say do the exact same thing really, and add the moon. This will make it so, it should make it so it layers it on top, so you have the moon over the top. And now, if we go ahead, and I believe we still have our PLT, yep, we'll go ahead and if we show this, we can run this, and we'll see what we have. All right, so from here, you can see, like, we have our sun, it's drawn in there, and then we have our moon, and it's off over, the center of it is off over to the side, right? And so now we have to kind of like make it animate through, right? And if you're feeling, extra creative, and you don't want to do this background or this be white, because hey, like, when you do the eclipse, everything gets dark, right? So we could do something where we set our face. So if I kill that terminal, we open up here, we can come up to this axis, we can say set face color, I believe it is face color, yeah. And then you can do the exact same thing. In our case, let's say it's not as dark, so 0.2. And if we rerun this, it takes a little bit longer when it's your video recording and trying to use this to run everything. Oh, whoops, one sec. I did not do that right. That's right, I remember this. So you don't actually want to set axis, you want to set it to the figure, because the whole figure, not just that subplot that you're dealing with. I was messing with this before, and I found that out because I tried to set the axis and it just wouldn't. And I'm like, I'm typing in the right numbers, and like I was typing in gray, I was giving it hex values, but you set it to figure. This now should actually work. All right, so just like that, you can see if we apply it to the whole figure, now we get this gray background, kind of symbolizing our night, our starry skies, and then we have our moon and our sun. Now all we have left to do is animate this. So let's hop right in and start the animation process. All right, so to animate this, essentially what we're going to say is our Annie is going to be equal to animation dot function animation. And from this, what it needs is, it needs your figure that you pass in. It needs the function that you're going to do, and we're going to say it's called animate. And then after that, it needs the frames. Now I'll show you what we're going to do there, but we're just going to pass in this number. So we're going to say frames is equal to the length of, and we're going to create a frames object here in a second called frames. And then after that, we're going to do an interval. Sorry, I've got some notes that I'm looking at just to make sure I don't mess this up. Is equal to and 50. Now what this interval does is basically kind of like the pause. I think it was the pause in milliseconds that it'll take in between each of these individual frames, right? And then we'll say blit, kind of like a redraw, I believe, if I remember right, is what that is. And blit is equal to true, so it'll just redo it for us. And then, so now we need to come up with this frames object and this animate object. And we're going to do the animate object first, and I'll explain why here in a minute, because actually it's really easy compared to what I was trying to do, right? So if we're going to create an inner kind of function that you can do in Python, and we're going to call this animate. We're going to put this up here, and it's going to just take in I. I is going to be that frame number. Now what this is going to do is this is going to allow us to kind of use the scope of what's already up here to kind of to grab everything and do some internal function stuff so it can help us animate. So what we're essentially going to need to do is, the goal of this function is we're going to have to get a certain frame or a certain position for our moon at a given interval of I, and then plot that moon position. So which is actually, like, since we're just kind of like moving from I guess this way to that way, left to right to left, however it is on your screen, we need to basically say we're just going to move our x-axis. The y is going to stay at 0, and the x is the only thing that we're going to move. So we're going to say x is equal to frame of I, or frames of I, right? And so the moon dot center now, so before the center, if we look up here, the center is a -2, 1. Now is going to be equal to x 0. And then all we need to do, whoa, messed that up. And then all we need to do is say return moon, okay? So now that's our animation function. It's basically going to go, every time we're looping through this frames. And if you give frames a number, what's going to happen is it's going to take a value and then just create this. So we basically, or it's going to go through the frames. I didn't explain that well, sorry. When you give it just a number in this animation function, from a previous video I did, I learned that when you give it just a number, it'll just start counting from that value all from 0 to like the length of the frames, right? And it'll just return kind of an index that you can then use with like a object like this, and then you can grab, you know, out your X value. So that means that we need to create this frames object where we are basically creating our animation of like, you know, at time step 0, you're at this position. At time step 1, you're at, you know, you've moved a little bit. And then the thing that I wanted to do, which I found this kind of hard to do in the beginning, was I wanted to go fast. So like over here is going fast and then slow, pause at the eclipse, and then start going slow, speeding up. Just go slow and then go back to fast, right? So that's what I wanted. So to do that, we kind of have to set frames at a certain, you know, at frame, you know, that means that like at frame, you know, 100, we need to like pause maybe for a little bit. You know, at frame, you know, 101, it's still the same thing. Or it's still the same thing. Frame 107, it starts to move again, slowly though, and then so on and so forth until we've got our eclipse passing through, right? Now, to do that, there is this thing with, and this is where the numpy array, the numpy package comes in. So we're going to create our frames object, and we're going to say that this is equal to np.concatenate. So this means we're just going to combine all of these kind of values together. And what we're going to do is create an array. And we're going to create several different arrays, right? So like I talked about, I wanted to go fast up to a certain point, slow in, pause at the eclipse, slow out, and then fast out, right? And so to do that, I found that if you use np.lin space, what this does is, this is kind of cool. So you have several different constructors for it and functions and how to use it, but kind of getting into it, this returns evenly spaced numbers over a specified interval. So this kind of helps us with our need of what we want from starting and stopping, right? And going fast and going slow. Returns num, evenly spaced samples, like I said, calculated from start to stop. The endpoint of the interval can be optionally excluded, which means like you can go all the way up to a point, and then you can get a new list that says starts from the next point and goes all the way to a certain point, right? So that's what we're going to use. So again, x started at -2. So we're going to say -2. That's our start. And then we want to go to -1. And we're going to say that this is 20. So we want to go 20 spaces, or like we want it to give us an array back of 20 values that are evenly spaced from -2 to -1. And we the endpoint we do not want to include, because then we're going to start from -1 and do our stuff. So endpoint is false. And if this doesn't make any sense, please leave a comment below, and I'll try and make sure I can clear this up, or maybe I'll even do a whole new video on this lin space, because I found it and I think it's really cool. It'd be cool to share with everybody even more. But essentially, so now the next thing that now this is kind of like the fast in, because we're only doing 20 frames, right? So we're fast in 20 frames, and then what I want to say is now I want to start from -1. So that's why we didn't include this endpoint. So basically this will go to like whatever the 20th value is right up until -1. So maybe that's -1.1 or something. I don't know. But it doesn't go to that yet. So then we're going to go from from -1. Now we're going to go to -0.5. And we're going to do this rather than for 20 frames, because that was quick. 20 frames was going to be quick. We're going to say we're going to do this for 50 frames. So this kind of starts to slow down the process, right? So now, as you probably guessed, we're going to do the exact same thing. And since we didn't include the endpoint there, we're going to say -0.5. And we're going to say 0. And then I'll just say that this is 75. So again, it starts to descend as we're getting closer. And what's cool is you can even do, 0 to 0, right? 0 to 0. And I'm going to say that this is 10, because we're going to do a brief pause for the solar eclipse, and now we're just going to start going all the way back up to 2. So we'll basically repeat all these things, but just in the opposite. So we'll go from 0 to 0.5, so 0.5, and we'll do that at 75, and then we'll do from 0.5 to 1, and then that'll be 50, because this is now speeding out, right? We've gone through the eclipse. And then last but not least, we'll do 1 to 2. So if we did everything right, and then we want to include this endpoint, because this is at the very end, right, that we're going to, so we're just kind of get rid of that. So if we did everything right and we run this, we should see our wonderful eclipse. And if I was able to use my notes correctly. But essentially, that's the solar eclipse. So we go ahead. So again, what this is going to do, this is going to create a giant list of numbers. And so from -2 to 1, you have 20 evenly spaced values. From -1 to -0.5, you have 50 evenly spaced values. From -0.5 to 0, you have 75. And then from 0 to 0, you'll just have 10. Basically, it should just say 0 10 times, I believe. And then from 0 to 0.5, you'll have 75, and then so on and so forth until we get to the end. And what that's going to do is basically those evenly spaced values, since the scope is up here, it's created up here. When we run this animate function, what's going to happen is we're just going to grab the value at that specific second in the animation. So so that interval of I in the animation, we're just going to say, hey, that's going to be equal to our X. We're going to set the moon center to X, which should slowly start to move that across our screen, right? So if we run this, right, and just like that, you can see, look, it came in fast. It started slowing down, and then it's probably even slower, a little bit slower now. And then you'll see that it will pause for the solar eclipse for 10 frames, and then kind of 75, and then or 50, and then it'll start to zoom off for the end. And just like that, you've got your own solar eclipse, and this thing will just keep repeating as much as you want, so you can swap out the glasses and get ready for the eclipse and enjoy what's going on, and don't get your eyes burned by the sun. So I hope that you found this valuable and you found this fun. I kind of like these little projects to do. So if you have any questions, please leave them in the comments below, or if there's anything here that you would like further understanding on, like that Lin escape function from NumPy, like that might be a great video. So if you have any questions, please leave them in the comments below. If you like this video, hit the like button. Until next time, keep on programming.